Hello everyone. In the last lecture we learned how to use the two-port model for a network to do circuit analysis using that model, and we practiced that on this specific circuit, and we showed that you just have to follow the same three-step algorithm, label the circuit, then write KCL equations for components, and only this time when you're writing the equation for components you would consider the two-port network as a component and write the equations for that component based on the two-port parameter models that we have developed. And then the math is going to give you whatever that it is you're looking for. Now, here I'm going to show you how to develop Thevenin model for part of the circuit using that, just as another example of how you could basically use the equations to develop the outcome that you're looking for. Now in this case, let's imagine the question is that we are looking back into port 2 and we are trying to develop a Thevenin model for everything looking back. So let me actually, so I'm gonna use a different color, and let's say that we are trying to put this whole part of the circuit into a box this time and develop a Thevenin model for that part of the box. So turn it into a V Thevenin and a Z Thevenin. So that's the question. So in that case, this part of the circuit is going to turn into a V Thevenin that is in series with a Z Thevenin. Okay, if you recall from a while back, the algorithm to do something like this goes as: for calculation of V Thevenin, you basically leave the port that you're trying to develop the model for open, and then look at that voltage. The voltage that you calculate would be your V Thevenin. And for Z Thevenin, you turn off any independent source in the circuit and then look back and calculate the equivalent impedance. The process could go like putting a test voltage here, looking at the test current going in and dividing the two by each other, and based on that you get Z Thevenin. So we're going to do the same. Now I'm going to show you how you can actually, you don't have to rewrite any equations here and use the same set of equations that we already wrote for the circuit, just basically understanding what's different. You can manipulate the same set of equations and get what you're looking for. And that shows you how the generality of these equations are powerful. You don't have to really rewrite them every time you want to do something else different. You can definitely rewrite them based on a situation, but you can just use the same set as well. So in this case, obviously you can see that ZL is not playing any role anymore. So the first thing that I'm going to do is to remove this equation that was written for ZL. So this equation was written for ZL, but what I'm trying to do here does not include ZL. So that equation is gone. And now the two situations that I have to do, I'm going to use the same three equations and add that condition to these three and then do the math. So the first condition that we're going to be dealing with is that the port 2 is open, which immediately means that I2 is 0 and therefore these two go away. So condition 1, I2 is equal to 0. And for that condition, now I have V1 is equal to Z11I1 and V2 is equal to Z21I1. There is no I2 anymore. This first equation is still valid, but these two have changed to this. Now I'm trying to calculate V2, and that's my Thevenin, so I can actually rewrite this right here, or say that this is actually my Thevenin. Okay, that said, I'm going to use I1 in this equation and this equation and calculate V2 as a function of Vg, and I'm done. So from this equation right here, I can calculate, replace I1 here, which gives me Z11 divided by Zg Vg minus Z11 divided by Zg V1, and move this to the other side, so V1 1 plus Z11 Zg, it's equal to Z11 over Zg Vg, and therefore from all that I have V1 is equal to Z11 over Zg and Zg plus Z11 Vg, which is basically a voltage divider between Z11 and Zg with respect to Vg. Okay, now I can use this equation and put it back into the first equation and find I1 as a function of Vg. So I1 is equal to Vg divided by Zg minus now this divided by Zg, which would be Z11 over Zg times Zg plus Z11 Vg. So now putting back that whole thing into this equation, I can calculate Thevenin. So from these two, I have Thevenin equal to Z21 over Zg minus Z21 Z11 over Zg plus Z11, this whole thing times Vg. That's my Thevenin. Now, if I want to continue and calculate, that's Thevenin. If I want to calculate Thevenin, now what's different with the Thevenin this time, the condition change, and what I need to do is to set Vg equal to 0. So once I put Vg equal to 0, I can continue. So the second condition down here, Vg, by setting it equal to 0, I immediately get that equation to turn into I1 is equal to minus V1 divided by Zg. And once I have that, then what I'm looking for this time is a V2 divided by I2. So I take these same three equations, these two, including this one, and this time I'm calculating V2 divided by I2. So I take this, put it in this equation. So V1 is equal to minus Z11 over ZG I1 plus Z12 I2. This was V1, sorry. So Z minus Z11 ZG V1 plus Z12 I2. So now I can move this to the other side. That's V1 times 1 plus Z11 over ZG is equal to Z12 I2. So from this I can calculate V1 as a function of I2. So now I can put this back into this equation, find I1 as a function of I2. So let me continue. Let me see if I can go slightly lower. Move this up. So from this I have V1 is equal to Z12 ZG over ZG plus Z11 I2. Put it back here. From this and this I get I1 is equal to minus Z12 over ZG plus Z11 I2. And with this I'm done. I can now take this equation, put it in the third equation right here, and therefore V2 is equal to minus Z12 Z21 over ZG plus Z11 I2 plus Z22 I2, from which I can calculate Z Thevenin, which is basically V2 divided by I2, and that would be Z22 minus Z12 Z21 over ZG plus Z11. So from these two I have developed the model, the Thevenin model for the part of the circuit that we discussed. It's going to be hard to show both the circuit and the equations, but now I have these two values for my circuit. Now I can put the ZL back in, and this has simplified to a simple Thevenin model connected to ZL. So you can see that you can manipulate these equations in different ways and calculate different values or parameters, or answer different kinds of questions. I'm going to put box around our solutions. So this is our Z Thevenin, and this was our V Thevenin. Thank you very much.